Hello everyone and welcome back to SSB Crack Exams. I am Chetan and in this session we are going to continue our topic of ocean currents. We have already done a session on ocean currents where we discussed mainly about the terminologies which are related with oceans, and also we discussed about the terminologies which are related with the relief features of oceans. I hope you have watched that video. If you have not, I would recommend you guys to go to our channel and you can watch that video. Now, in this session, we are going to cover about factors affecting water movement, and we are only concerned about the oceanic water movement, the factors that affect the oceanic water movement. So let's start. Before we start, let me tell you about SSB Crack Exam. So this is a one-stop solution for all the major defense-related examinations like AFCAT, CDS, NDA, CAPF, etc. For more details regarding the meticulously designed courses that we provide for you guys for this examination, you can visit to our website learn.ssbcrackexams.com. You can also subscribe to our YouTube channel, and you can also download our Android app from Google Play Store, that is SSB Crack Exams, wherein you can also download the lessons and the study material that we provide. Now let's start. First of all, let me tell you about what all we are going to cover in this particular session. So like we have already discussed, I'll be telling you about mainly the factors that affect water movements in the oceans. And when I'm talking about the factors, I'm mainly concerned about the major factors, the primary factors that affect the water movement. The first we are going to discuss is about temperature distribution in water, then salinity of water, tidal waves, atmospheric wind circulation, and Coriolis force. Now these are the primary factors that affect the movement of oceanic water, and we are going to discuss each of these in detail. So let's start. First in our list is temperature distribution. Now you must know that temperature of the oceanic water, it varies with depth as well as the latitude of the earth. By depth, I mean that as you go the water level of sea to the deepest part of the ocean, then the temperature varies. That is also known as a temperature distribution in the vertical direction. The next in our list is latitude. That is, if you change the location of your place on earth, that means that if you change the latitude and the longitudinal position of yours on any place of the earth, then also you'll observe temperature distribution. And with a change in latitude, you'll also observe change in the temperature of the oceanic water. And we'll discuss that also. That is also known as temperature distribution is horizontal direction. Now, one thing that you must know before we move ahead is the fact that land and sea has different rates of releasing of heat or absorbing of heat. Now, heat in what form? We all know that we receive heat in the form of sunlight from outer space, from of course sun. So land has the capability of releasing heat or absorbing heat at a faster rate than sea or the water. And water absorbs or releases heat in a slower rate than land. And how will this be useful to us, and how will be this put to an application, and how we'll be able to understand this particular facts? We'll discuss that also when we'll discuss about it, and we'll see the application of this. Let's move ahead. First of all, I will start off with the temperature distribution in horizontal direction. That is temperature distribution with the change of latitude. Now, it also depends upon several factors. The first factor is simply the latitude. The temperature of the surface water decreases from the equator towards the poles because the amount of insolation decreases poleward. Now, this is a very interesting one. If you look at this figure, you can see that there is several temperature difference which changes with the latitude. We know latitudes are the parallel lines drawn to equator of our earth. So if this is the equator, as you move ahead from, or if you move away from the equator, you'll see the temperature change. The red color in this particular list shows the highest temperature. The light purple shows the lowest one, and the temperature decreases in this direction. And if this is the equator, I'll change the color so that you can see this. So if this is the equator, this is actually the position of equator, then as you go away from equator, then you will see that there is a change in temperature, and the temperature is actually gradually decreasing, right? Now, why does this happen? This also has a reason. Now, we all know that we receive the heat in the form of sunlight from sun, right? And the sun, for example, let me explain you this. The sun hits the equatorial region. The sunlight falls on the equatorial region for almost all the time of the year, right? And it does not fall for all the time of the year in Arctic Circle. Now, what happens is also one of the reason is that In the equatorial region, the density of sunlight is quite high, or the intensity of the heat energy is quite high. Why? Because it falls directly onto the surface of equator. But the same amount of sunlight, when it falls on the Arctic region, then it falls on a slightly greater area. This is because of the spherical shape of Earth. Now, since the same amount of sunlight is falling for a greater amount of area, this means that the sunlight becomes sparse and it gets distributed evenly, right? And due to this, what happens is that the intensity of the sunlight, or the intensity of the heat energy, it decreases, and thus there is less amount of heat which is received by the regions which are away from the equator, right? So this is one of the reasons why we see a decrease in temperature. There can be many reasons that collectively account for the decrease in temperature in the polar region, but this is also one of the major influencers. So this is the ideal case. Now what actually happens is that we all know that our Earth is tilted about its axis. So equatorial region is that particular region where the sunlight is received throughout the year almost. But during summer solstice, the sun directly falls instead of equator, it falls directly at the Tropic of Cancer, right? So when the Earth rotates, then all the regions which are near to Tropic of Cancer, they will receive the sunlight throughout the summer season. And during winter solstice, it will be received by Tropic of Capricorn. So since the water level, or the water which is present, or the oceanic water which are present in the equatorial region, they receive the sunlight throughout the year, so the temperature over there remains high only, right? But in Tropic of Cancer or near the Tropic of Capricorn, what happens is that since they receive the sunlight directly only during their summer season, so the water over there gets heated up only during the summer, and they do not remain heated up, or the temperature over there it does not or the temperature over there it does not remain high throughout the year and only during the summer season. So I hope this concept is now clear to you all. And this is obviously seen now, I hope this is more clear to you all, that why we see the temperature difference as we move away from the equator, and why do we only see the highest temperature in equatorial region and the lowest temperature in the polar region. Now, let's move ahead and discuss the second factor. The second factor is unequal distribution of land and water. Now, remember I told you guys that the land absorbs heat faster than the water, right? And if you look closely at the earth, and if I'll open this earth into a flat surface, then what you'll observe is that the number of landmass, or the area of landmass in the northern hemisphere is slightly more than the number of or the area of land in the southern hemisphere. For example, in the northern hemisphere, you'll observe the entire continent of North America, the majority of the part of African continent, then we have Europe, and of course the Asian continent. Entirely almost 90 to 95% of Asian continent lies in the northern hemisphere. So the land part, the surface area that has land, is more in the northern hemisphere. And since land receives heat quickly and it gets heated up quickly, thus the water in the northern hemisphere is slightly more, the temperature of water in the northern hemisphere is slightly more than the temperature of water in the southern hemisphere, right? So there is a slight temperature difference, not a very drastic change in temperature, but a very slight temperature difference. So how does it affect? This affects in a way that ideally it should be like, for example, if the earth was not tilted and the land distribution was almost even in both southern and northern hemisphere, then the maximum temperature should have been at the equator. But due to these two reasons, since we have a tilted axis of earth and also the uneven land distribution, the highest temperature is slightly shifted in the northern direction, and it is observed somewhere over here. I hope now this is clear to you all, right? And the average temperature lies approximately between 25 to 28 degrees Celsius of water. Let's discuss the third reason. The third reason of temperature distribution in horizontal direction is the prevailing winds. The winds blowing from the land towards the oceans drive warm surface water away from the coast, resulting in the upwelling of cold water from below. It results into the longitudinal variation in the temperature. Contrary to this, the onshore winds pile up warm water near the coast, and this raises the temperature. This is basically the concept of sea breeze and land breeze. Let me explain you this. Again, this is also related to the concept that land gets heated up quickly and it also releases heat quickly. So what happens during the daytime, and that too in the coastal region only, is that warm air from the land. And why warm layer is found above the land? So what happens is that when the sunlight is received by both the land and the sea, the land gets heated up quite quickly. And since the land gets heated up quickly and relatively quicker than the water or the water body, be it any sea or ocean, the air which is present above the land, it also gets heated up. And we all know that when air heats up, it expands, the density of air decreases, and it tries to move up, right? So when it tries to move up, there is a void created. Now this void is filled up by the relatively cooler sea breeze. So the sea breeze comes from the seaside to the land side to fill up this void. The void which is created by the movement of sea breeze is again completed by this warm air, and thus a cycle is produced. And thus in the daytime, you'll see in the coastal region that there is a movement of cold sea breeze from the seaside to the land side, and warm air goes to the seaside and completes the cycle. This is known as sea breeze. Exactly opposite happens during the night time. Now what happens in night time? The land quickly loses the heat which is acquired by the land and water both during the daytime. So since the land quickly releases the heat, the seawater still remains heated up as it releases the heat slowly. So now the seawater heats up the air which is present above the sea, and now this area has the warm air. Now the same cycle happens. That means that the warm air expands, it goes above, then the void which is being created is filled up by the slightly cooler land breeze, and then it fills the void. And of course, the void which is being created by the cooler breeze, it is filled up by the warm air. So a reverse cycle is formed, and a cooler land breeze is observed in the sea. This phase is called as land breeze. Okay, now these are the two phenomena which also regulate the temperature of sea water in the coastal region. However, it does not drastically affect the movement of oceanic water, but it definitely affects the temperature distribution. The next in our list is the temperature distribution of horizontal direction due to ocean currents. Now, you might be wondering that we already are seeing the factors that affect the movement of ocean and the ocean currents, and temperature distribution is also one of them. So these two are actually interlinked with each other. That means that temperature distribution in horizontal direction, it is also regulated by ocean currents, and ocean currents is also one of the reasons that affect the temperature distribution in the horizontal direction. I hope this is clear to you. The next in our list is temperature distribution in vertical direction, that is the change in temperature with respect to depth. The temperature depth profile for ocean water shows how the temperature decreases with increasing depth. Now the figure on your left, you can see a graph. This is a graph which shows the variation of temperature starting from the sea level, that is 0 meter depth, to up to a depth of 4.5 kilometers. Now the sea is divided into various parts, three basic parts: first layer, second layer, and the third layer. The first layer is the topmost layer, which accounts for only 10% of the sea surface water by volume. The second layer is a thermocline, where you'll see drastic change in the temperature. The third one is the deep sea area, which covers approximately 80 to 90% of the entire sea volume water. So let's see each of these layers one by one. The first layer represents the top layer of warm oceanic water. So whatever the temperature distribution that take place in horizontal direction that we have seen up till now, that takes place in this first layer. It could be as deep as just 500 meter, and they have a thickness of around 500 meter. And the temperature in this region ranges from 20 to 25 degrees Celsius only. This layer within the tropical region is present throughout the year, but in mid latitudes it develops only during summer. Now we have already talked about this. Since the equatorial region or the tropical region receives sunlight throughout the year, so this warm layer remains throughout the year, while the mid latitude regions, that is near Tropic of Cancer or Tropic of Capricorn, this particular layer is formed only during summer season, right, when they receive direct sunlight. The next layer is the thermocline layer. This is called the second layer, which comes just after the first layer. Its depth is around 500 to 100 meter, 1000 meter, pardon me. It could be as thick as 500 to 1000 meter, and this region is called as thermocline. You'll see rapid decline in the temperature in this particular region, and starting from 20 to 25 degrees Celsius, depending upon the temperature of the first layer. In this particular region, you'll find that the temperature decrease is approximately about 12 to 15 degrees Celsius, right? And that is a very sharp decline for just 1000 meter difference. Now, the third layer is very cold and extends up to deep ocean floors. Especially in Arctic and the Antarctic circles, the surface water temperatures, which are also close to 0 degrees Celsius and already close to 0 degrees Celsius, and so the temperature change with the depth is very slight. Here, only one layer of cold water exists, which extends up to the surface to deep ocean floors. Okay, now we are done with the temperature distribution of both horizontal and vertical. Salinity. Now, what is this salinity? So, we all know that all waters in nature, whether rainwater or the ocean water, contain dissolved mineral salts. Salinity is the term which is used to define the total content of dissolved salts or dissolved minerals in sea water. Now, let's check out the factors that affect the variation of salinity in ocean water. The very first factor is, of course, evaporation and precipitation. The salinity of water in the surface layer of oceans depends mainly on evaporation and precipitation. And how does this affect? So let me tell you that too. So what is happening during the daytime when the sea surface water is exposed to sunlight? Then what happens? Of course, there will be evaporation that will take place. So evaporation, due to evaporation, only the pure water and not the minerals, only pure water, they get evaporated and then they form clouds, right? So what happens due to this? Due to cloud formation, now earlier, for example, let's say 100 liters of water had, for example, let's say 50 grams of minerals, which is the salt concentration. But after evaporation, since majority of the water got evaporated, now the salt left in 1000 liter of water is more than 50 gram. It is, let's say, for example, 75 grams. Now this means that the concentration of that particular water is increased, thus the density of that water increases. Now what happens if the density of water increases? That particular water gets heavy, it becomes heavy, and then due to the fact that it becomes heavy, it tries to sink in and then goes in the deeper depth of the oceans, right? And this is how a new circulation is formed in the vertical direction. And that is why I said that salinity variation occurs mostly, and it basically mostly triggers the vertical circular motion of the water. The next factor that we are going to discuss is the salinity variation in ocean water due to hydrological cycle. Now what happens in this? Now in this case, what is happening is that the evaporated water is actually getting precipitated in some other part. For example, it could be precipitated, or the rainfall could take place in the form of rain or snowfall on any part of the land and not on the ocean. So of course, this will also affect the overall salinity and the concentration of water in the oceans. So that is how also it is affected. Now, of course, it is greatly influenced in coastal region mainly by the fresh water flow from rivers, and in polar regions by the process of freezing and thawing of ice. That means that when these precipitated water falls on the land, they form lakes and rivers, and those rivers or those snow which are formed in the Arctic and Antarctic region, these are the form of or the source of fresh water. When these fresh waters gets added up, or when they get for example, the waters are dropped inside the ocean from the rivers, or when these ice melts inside the ocean, then of course there is a change in concentration, and of course there is a change in the salinity of the water over there. So this is how this region affects. So this is how this factor is responsible for the variation in salinity. The next in our list is the winds. So winds also influence the salinity of an area by transferring water to other areas. We all know. The next in our list is salinity variation in ocean, and we'll see the global salinity variation of salt water. Now I'll explain you by the help of this figure how the global salinity is affected all across the world in the oceans. So if you look closely in the Arabian Sea part of the near the Arabian Peninsula, between the Arabian Peninsula and the Indian Peninsula, you'll see that the red color shows the maximum amount of salinity. So why maximum salinity is observed in this particular region is because of the hydrological cycle. That means, and that is of course because of the effect of Indian monsoon. So what happens? Majority of the water in Arabian Sea, it gets evaporated and it gets converted into the form of clouds, and then they move to the Indian subcontinent side during the Indian monsoon. And of course those water gets precipitated in the of course on the lands of Indian Peninsula, Indian subcontinent, and of course that salinity level is not maintained in the Arabian Sea. The same reason is applied for Mediterranean Sea also. Majority of the water gets evaporated and uh, it gets precipitated in these parts of the Europes and the Central Asia, and this is the one of the major reasons why we see such high level of salinity in Mediterranean Sea. You'll also notice that the most saltiest lake, one of the most saltiest lake on earth, is the Dead Sea, which is also present in this region only. I hope this is clear to you. Moving on to our next factor that affect the movement of water is the tidal waves. The periodical rise and fall of sea level once or twice a day, mainly due to the attraction of sun and the moon, is called a tide. Why does this happen? This is simply because of the gravitational pull of the ocean. Now we see that why do we see the changes in ocean waters only due to the gravitational pull and not on the land? So one of the biggest reason for that is of course the fact that the water is loose in its structure as far as its structure is concerned. For example, it does not have its own shape, and land is fixed and it is stiff in form, in structure. The structure of land is always fixed. Water is loose. That means that if there is any significant amount of gravitational pull, of course, it will affect the shape of that particular water. So whenever there are two cases, that means that when sun, earth and moon are in line, then there can be two cases, of course. Either the moon is between earth and sun, or the earth is between moon and sun. In both the cases, what happens is that both the celestial bodies, sun and moon, they apply their gravitational pull on the water of earth, and water being of course loose in structure, it gets attracted towards these celestial bodies, and there is a formation of tidal bulge, as you can see over here in the figure. Okay, now these area where you can observe the tidal bulge, these areas experience high tides, or these are known as spring tides, when sun, earth and moon both are in line. The areas which do not see the tidal bulge, there is the formation of low tides. Similarly, there is a second case when the moon, earth and sun, they form a right angle. They are at right angle with each other, right? And in this case, what happens is that the tidal bulge is somewhere in this particular position, which is in the direction of moon. And now this will be the part that will of course experience the high tide, and this will be the part which will experience the low tide. This formation, when these three celestial bodies form a right angle, then the tides which are formed in during this time is known as neap tide. The next in our list that affect the movement of water is the atmospheric wind or circulation of these wind. The friction between the wind and the water surface affects the movement of water body in its course. We all know how the waves are formed. Due to movement of air, there is formation of ripples, something like this as you can see in the figure. Now these ripples, they collectively form a larger wave. Now those waves are responsible for the movement of water and mainly the upper surface or the upper topmost layer of the sea surface or the oceanic water. So they are also responsible for the movement of seawater. The next and the most important one is the Coriolis force. The Coriolis force not only regulates the motion, or not only responsible for the motion of oceanic water, but also for the motion of the atmospheric circulation or the atmospheric winds. Now this is mainly a pseudo force, which is of course due to rotation of earth. Now how does this affect? We all know that our earth moves from west to east direction. Now what happens is that due to inertia, since the water and the air that is present in the atmosphere, both of these are not stick together, both of these are not sticked with the surface of the earth. They are free to move, right? They are loose in structure. That means that when the earth will rotate in this particular direction, due to inertia, they will have a tendency to remain at the same place. But due to relative velocity, what is happening is that if you'll stop seeing the earth that it is moving, then you'll notice that if earth is not moving, that means that relatively, by the concept of relative motion, the earth's wind and the water which is present on earth, they will try to move in this particular direction, in the opposite direction of the rotation of the earth. So in the equatorial region, in the northern area, due to the spherical surface, the movement of air is something like this in this particular direction. These are known as northeasterly trades. Similarly, in the region which is just below the equator, which is southern side of the equator, you will find southeasterly trade winds which move in this particular direction. Now, this is also the direction which is same for the ocean currents as well. The oceanic water also move in the same way only. And when I'll explain you the mapping of the major currents, then you'll get to understand how this Coriolis force is actually affecting, and in fact, it is the reason why the oceanic currents starts to move. So I hope this entire session was helpful for you all, and you got to learn and understand the concepts about the factors that affect the movement of oceanic water. The next and the last session on ocean currents will be discussing mainly about the ocean currents only, their major currents, minor currents, and their mapping on the world map. Till then, stay tuned to SSB Crack Exams. Thank you. Jai Hind.